conditional probability of event A, given that event B has already occurred, is called the conditional probability of event A given event B. It can be represented like P of A given B, and mathematically it is always equals to probability of A and B over probability of B. Hence, probability of conditional probability of B given A has already occurred be given by P of A intersection B over probability of event A. One important relationship of the conditional probability, that probability of A or B given event E, it is given by probability of A given E plus probability of B given E minus probability of A given A and B given E. If A and B are disjoint, A and B are two disjoint events, then probability of A or B given E is equals to probability of A given E plus probability B given E. Let's take an example of this conditional probability. So in a school there are 500 students, out of which 200 are girls. It is known that out of 260, 10% of the girls study mathematics. What is the probability that a student chosen randomly studies mathematics given that the chosen student is a girl? So there are two events. One of them we called it is a girl student, and the event B is defined as the student study mathematics. Now we are given the probability of A that 260 out of 500 are girls. So it is equivalent to 0.52. While 10% of the girl study mathematics. So it means that probability that a girl student study mathematics is P of A and B, and this is 10%. So it is 0.1. Now we have to find the probability that a student which is chosen randomly studies mathematics given that the student is a girl. So we are given that it is a girl, so we are given A and we have to find B. So we have to find probability of B given A, which should be equals to P of A intersection B over P of A. So it is equals to 0.1 over 0.52, which may be 10 over 52 or 5 over 26. Now discuss another example. Given that two numbers appearing on throwing two dice are different, find the probability of the event. Thus, sum of the numbers on dice is 6. So there we can define two events that the numbers appearing on dice are different. Number on dice are different. We can define event B as that sum on dice is 6. So the numbers are different, then n of A should be equals to 30. There are 30 such outcomes out of total 36 in which the numbers are different, and 6 outcomes have same numbers, that is 1 1 2 2 3 3 4 4 5 5 and 6 6. And the event B, the sum on dice is 6. So we should have the outcomes like 1 5 or 5 1, 2 4 or 4 2 and 3 3. So the common of them are these four numbers, which are these four outcomes 1 5, 5 1, 2 4 and 4 2, because these are different outcomes. So probability, we have to find that the sum on dice is 6 given that the numbers are different. Okay, so probability of B given A needs to be calculated, for which I need P of A intersection B over P of A, because these two probabilities are out of the same experiment, so it may be equal to N of A intersection B over N of A as well. So N of A intersection B is 4 while N of A is 30, so the answer should be 2 over 15. Let's discuss another example, which is in a test 25% student failed in mathematics, 80% passed in physics, while 10% failed in both subjects. So suppose A is the event uh, that student fail in mathematics and B is the event that student is fail in physics. Now we are given the outcome as P of A, which is 25%, or it is 0.25, while we are given that the student does not fail in the physics subject, so it is not B, which is 80% or zero point 0.8. So the probability of event B should be 1 minus P not B, which is hence 0.2. And we are given that the student fail in A and B, so it is probability of A and B, A intersection B, which is 0.1. Now we are given the condition that a randomly selected student, if failed in physics, what is the probability that he also failed in failed in, if failed in mathematics, what is the probability that he also failed in physics. So we are given the failure in mathematics, so given A, we have to find the probability of failing in physics, that is B. So it should be equals to P of A intersection B over P of A, and P of A intersection B is 0.1 while P of A is 0.25. This outcome can be equals to 10 over 25 or equal to 2 over 5 or equals to 0.4.